Okay, good morning, everybody. When Ramon invited me to do the speech, I thought that would be a good idea at this opening piece. I thought it would be a good idea to try to at least present the view that from SAIL that we have on the future of the internet. But before I'm going to go through far in the future, I'm not really a visionary. I cannot predict the future in 30 years from now. I can, at least based on the trend that we see in the last few years, I can give a direction where the future internet will be. Especially from SAIL, where we want to apply our results and solutions in the near future. It was good to maybe look back a bit at what happened in the past, to see how internet is used today and how it could evolve in the coming years. And one thing that we need to understand is what we should take for granted in the coming years. There was a few things that didn't exist a few years ago, and now that we take for granted. So, for example, how much of you has booked a movie ticket from the web? How much? Yeah. A few years ago, that could not happen. Now it's quite easy. I mean, if you take a smartphone with, and we get an LTE connection, with the next generation of LTE will be able to do 1 gigabit of download and 500 megabits of upload. So getting your information from the movie theater will be quite quick. So in a few seconds you'll be able to get the schedule of the movie, be able to look at the trailers, get some comments from your friends. You're going to be able to see the bio of the actors. You're going to be able to buy the ticket and maybe coupon for the popcorn. But the coupon, you don't need to print them. You're going to get as a QR code on your phone. And then, of course, all through that, you're going to get some advertisement. A few years ago, when I started to study in computer science, my first programming assignment, I did it on a machine like that. You know what that is? That's a machine to punch cards. Then you punch the card with holes. Then you put those cards in the reader. That's the way that you get the input to the machine. And in fact, you get some cards like that. How much of you have seen those cards? Yeah. So this is my first computer assignment. I did it on that. So no way you can book tickets using that interface. And this is the size of the computer you had. I mean, from what fits now in a phone, used to take a full room just to do the same computing power and same storage. I've been lucky on my first computer assignment. I was allowed to use the paper terminals. This terminal it runs about 300 buds per second, which means 300 different signals during the second. So in average, you get something like 75 bytes per second. You're a bit far from this 1 gigabit per second that you get on the LTE phone. So if you want to display one of today's web pages on that paper terminal, I mean, at 300 baud that get you 75 bytes per second. The average web page today contains about 80 objects from different sites. And you in average, you get something like 700 kilobytes of information that you need to transfer to your browser. So, which means that on this paper terminal, that will take you about 2 hours just to download one page. So if you want to go to that movie example again, you'll probably go to about 10 to 15 pages at least, which means it's going to take you 25 to 30 hours. So you better plan in advance if you want to go to the movie. And one problem which is not solved for that is, how do you view a movie trailer on a paper terminal? Okay, that was the past. So what do we have on internet today? We have mainly content. A huge share of the traffic is related to content. Video, pictures, music, and so on. That represents a large share of the consumer traffic. Another aspect which is important today in internet is the elastic demand. From one day to the other, the actual demand on the application or the services may vary quite largely in time. So you need to make sure that your application and the resources that you deploy for your application is also able to vary in time quite rapidly. And of course, everything is about connectivity and mobility. Now, everybody has a mobile device that can connect in different ways to internet. With my laptop, I can connect via Bluetooth, via Wi-Fi, via 3G, and even fixed. I mean, I can even connect with a cable with my laptop. So the solution that we need to develop needs to be able to fulfill those requirements. So what we have done in SAIL is that we look at three main technical solutions or three different sub-topics on how the internet should evolve. The first one is to address the content aspect, and it's related to information-centric networking, and it's about network of information. That's the ICN flavor of SAIL is network of information, NetInf, and this is to address content. I'm gonna get a few words on that a bit later. The other approach is cloud networking. I guess you're aware already of cloud computing. We're adding the networking aspect to that to be able to connect the different data center to better use the network as a resource in the cloud topic. And the third one is about open connectivity services, OCONs, where we define or refine a set of services to be able to support NetInf and clone to better connect all the devices and the people that we have. In SAIL, there's mainly three use cases or three scenarios that we're looking at. The first one is the event with large crowd, where we, for example, we get a royal wedding with all the people that get together, or if we get like lately that we have in Montreal a huge amount of students that get together because they were on strike and they want to get the tuition fees to be reduced. You get all those people that get together, and then there's not enough resources in the network to sustain that. So we need to find a way to make sure that they can communicate or exchange content between them, maybe without the support of the network. And yeah, so they need to be able to exchange information without the support of the network. The second use case that we're looking at is the dynamic enterprise. In fact, in that case, we imagine that an enterprise that might want to deploy an application, maybe not in a single country, but in multiple countries, should be able to allocate the resources both in data centers, but also in the network to be able to sustain that application. And also the resources that are deployed for that application should be able to increase according to the demand or decrease if there's no demand anymore. And finally, the third use case that we're looking is a combination of the two. So where we have the network of information, which is considered as an application that can run on top of cloud networking, where depending on if there's demand in a new part of the network, then we should be able to allocate new resources for NetInf to be able to serve those users by deploying new caches, new routers or new ICN nodes in the network to support all of that. So this is mainly the three use cases that we have. So I'm going to say a few words about ICN. I won't go into much in details on that, but I should say just to say a few words. First of all, the prediction, Cisco every year they come up with some prediction on how the traffic will look like. So these are the predictions from Cisco from last year. They plan that somewhere in 2015, 2016, 80% of the consumer traffic will be content sharing, either peer-to-peer, video, music, and so on. So that's represent about 80% of the traffic. So somewhere we need to address that. So NetInt is trying to address that. One, I mean, in the past, what we have done mainly is trying to connect nodes. We have nodes from different places. We connect them, and then we try to fetch the content from one by connecting to a node, a web server somewhere, and then we download that content. But what we would like, already there's been solutions to try to break the fact that the content should be in a single place, but can be spread in many places. And for example, we get content delivery network that are put in place to try to accelerate the access to the content, or the peer-to-peer, which also that tries to make sure that you can get the content without knowing exactly where it resides. What we would like to do is to, rather than having those features around the network, as you know, as an overlay, try to introduce that inside the network to support all of that. So it's going to increase the performance and the efficiency of the content retrieval. So one way to do that, for example, is to put some in the different nodes in the network, to put some caches where you can store the content. So for example, if you have a user that wants to retrieve the object from Joe, so we can send requests to Joe to get the content, and then as the content is sent back to Joe to the user, then we can keep copies of that in the network. So all the way on the way back, we can keep copies of that content. So when the next user is going to try to retrieve the same content, instead of getting directly to the end, to the content provider, we can get it from the first copy that we find in the network, and then just send it back, and saving network resources and increasing the performance. But there are a few challenges to be able to achieve that. First of all, you need to make sure that you name the information uniquely. If you have a movie file, or if you have a picture, or if you have a song, you need to make sure that you name it uniquely. So for any user that's going to try to retrieve it, going to retrieve it with using the same name. So instead of using URL, where you're going to get the host name as part of the object ID, you should try to remove that part where you put the location or the server where you're going to retrieve that, but instead put maybe who is the provider of the object, which was the entity that provides the object, and then put the name of the object. So that the object names can become keys on the actual for the actual content file. And of course, you need to make sure that the name can be uniquely related to the content, so that you cannot use the same name for multiple for different content. The second challenge that we're also investigating is the routing and name resolution. Based on that, once I have that unique name, I don't know where I'm going to find the object. Where do I retrieve that? And also, how do I route back if I'm not using node name anymore in the object name? Do I make sure that my request to get the object gets to the right place? And how do I make sure that the object is transported back to the requester of the object? The other challenge is about caching. What should I cache? Where should I cache it? For how long should I cache it? And try. We need to find a way to. We cannot on a single router cache all the content that can be retrieved from a certain area in the network. So we need to decide which one we're going to cache. And also how should we should we do proactive caching? That is, I know that this content will going to be popular, so I'm going to already put it in the network. Or should we do reactive caching, where we have that many requests on that content, so I'm going to then decide to save a copy. And then transport, I kind of related to the routing and forwarding. How do I transport the object? If I have multiple connectivity type, for Wi-Fi, 3G, and so on, how do I make sure that I use all those connectivity in the best way? How do I make sure that I forward the content properly without creating congestion in the network? And how do I react to congestion in the network to maybe fetch the content from somewhere else? And finally, the fifth challenge I want to mention is security and trust. Now that if we don't have this end-to-end connection, end-to-end trusted connection between a user device and a server, how do I make sure that the content that I want is the right one? How do I make sure that I care about privacy? How do I make sure that how do I make sure that the user that's going to read that content was authorized to get that content, and so on? So that's one of the issues that we need to address. But I won't go too much in detail more than that on information networking, because on Wednesday morning and on Thursday morning, there are going to be full sessions dedicated to that. So we're going to have Professor Carl from Paderborn University, and also Matteo D'Ambrosio from Telecom Italia, that's going to present some of the solution that we have for ICN in Sail. And on Thursday morning, we're going to have Luca Muscariello from Orange that's going to come to discuss some of the caching techniques and some of the research results that we have from Sail. Okay, now cloud networking. That's the second kind of main topic that we have in Sail, cloud networking. I guess you all seen all those recent machines. Getting a running server in the old days. Who have tried to install his own PC starting from scratch? Yeah. In the old days, getting a running server was quite an exhaustive task. You need first to get the latest paper catalog, because getting to internet was a bit slow, so it was much faster to go to the store, get the catalog, and browse through it to get the pieces the PC that you want. And then you order the computer parts. Usually they don't. Sometimes the PC didn't get fully packed as it comes today with laptops. So we need to order the hard disk from one side, the monitor from the other side, and so on. And then sometimes you need to wait a few weeks to get the delivery. Then you install all the hardware. You fight to write the right cables. Of course, the cable never fit. And then you install the operating system using the 22 floppy diskette that you need to put one by one in the machine. Sometimes we're putting the same one more than once. Okay, and then usually when you get those 22 floppy diskette, then usually most of the driver that you have on your PC, because you want to save money, you buy a cheap one. So the NIC card or the mouse driver was not included in the operating system, so you need to fight to find the right ones. And sometimes you even need a screwdriver to be able to install software, because sometimes for example the drivers require some setting on the NIC card. You need to remove jumpers manually to make sure that you get the right configuration. Yeah. Okay, getting a running server today. How do you do that? Anybody have a good idea how we should do that? It's easy. You open a browser on your smartphone. You connect to your preferred cloud provider. You create a virtual machine with your preferred operating system, and you connect to the machine. That's it. much easier with kind of different work. So, yeah. So welcome to cloud computing. Now, what PC used to be kind of a strange beast now become utility. You can get access to servers quite easily. You can get access. In fact, if you you connect to Amazon, you can even connect to you can get a kind of 1 year free server from them without paying anything. So getting servers is quite easy, and now computing is now, as I said, a utility. You don't need to fight for that. It's much easier. So, but what cloud is? So before we can mention a bit more about cloud networking, we need to know what cloud computing is first. So NIST, which is the National Institute for Standardization and Technology from the US, they come with 5 characteristics of what cloud is. First of all, it needs to be on-demand self-service. You don't need to call someone to get something. You should be able to do it like from the web directly, or even from API, which are available from other applications that you can have in your environment. Second, it needs to be ubiquitous network access. That means anywhere in the world from the internet, you should be able to access those machines. Location-independent resource pooling. That means you're connected to those machines, you don't know where they are, you don't know where they come from. Also, if you ask for a new machine, it won't be from a dedicated server to you. It's going to be from a pool of resources that for which you're gonna have access to. The fourth one is rapid elasticity. That I've mentioned that earlier. Is you need to be able to rapidly be able to add new computing resources, or maybe release some computing resources because you don't need them anymore. And that's one aspect important, is that this should be done rapidly. That should not take weeks before you get rid of your computer, or that should not take weeks before you get access to that computer. That should be done in minutes, or maybe even in seconds. And finally, there's going to be a pay-per-use. If you shut down the machine, you don't use it, you don't pay for it. Same thing, if you use a lot of network resources between your virtual machine, then you should pay for the computing part of that, and maybe for the computing or the storage part that you're going to use. Cloud computing is not only about servers, but a bunch of servers that we include in cloud computing. First of all, they're kind of a stack of servers that has been defined. One is infrastructure as a service. This is getting a new server for you, getting your own servers where you're going to have access, maybe be able to connect them, be able to allocate some storage. An example of that are Amazon, GoGrid, Joyent, Rackspace. They're providing you virtual resources, computer and storage for you. The second one is platform as a service. In that case, you don't really care about the physical machine. You don't really care about the servers themselves. You more care about the platform where you're going to run applications. For example, if you want to run a web service, you don't care about how many servers you're going to need. You don't care about the load balancing that you need to do between those servers. You just need caring about, I'm going to receive an HTTP request, I'm going to handle that in some way, and then I'm going to send a reply to that. So you care more about the application level. You don't care about physical or connectivity servers, load balancing, and firewalls, and so on. The provider of the cloud service provides you all of this. Usually it comes even with a development environment where you're going to be able to create your own application, add features, and so on. Example of that are Google App Engine, where you can deploy quickly application. Windows Azure is also an example of that, and Force.com also provides some platform specific for some specific application related to sales and customer management. And then on top of that, Then you can have software as a service, where in fact the full software is provided to you. You use the software from the cloud, from the internet, without really to have to manage the application itself. So you're only the user of the application. You're not the only one. You might have a specific environment for your enterprise, but that's you don't need to care about all the infrastructure that's required to run that application. Example of that are, of course, all the Google application, Gmail, Google Docs, and so on. Windows Live, Salesforce, which provide a full software as a service for customer management and so on, and orders and all that. SAP also provides some of those things. And cloud types. You can have either public cloud, that's an enterprise that owns all the resources. You subscribe to that. And all the resources provided that provider are shared between all the customers of that provider. Example of that: Amazon, Rackspace. Private cloud. In that case, what you do is you create your own data center and use the virtualization aspect to be able to manage the resources as if you were in the cloud. The most provider out of that is VMware, that owns I think that controls like something like 90% of the market into that. And finally, of course, you have the hybrid cloud, where your application that you need either run partly in your private cloud, and you may extend it into the public cloud, either because you don't have enough resources in your own data center, or because you want to offer some of the services to maybe people on the other side of the planet, and you want to deploy a data center on that side of the planet. But what's missing in all these is that currently cloud computing is about computing, having servers, and storage, having uses where you can store the information and you get the electricity. It's very little about networking. But networking is quite, if you want to get access to the servers, if you want to get access to that your server can access to the customers, you need the network in between. So in SAIL, we're looking at that. We're looking at cloud networking. What does that mean? First, it means that you need to be able to provide dynamic connectivity services between the enterprise and the data centers, or between the different data centers. If you deploy an application in more than one data center, then you should be able to connect those parts of the application dynamically. And that should go as quickly as creating the virtual machines. There's no point. Currently, if you want to create a VPN from two different sites, you need to call your preferred network operator, and sometimes it may take weeks before you get the connectivity in your VPN. That should not be the case. If you're able to allocate virtual machines quickly, you should be able to connect them many of them as quick as you create virtual machines. So on-demand, pay-as-you-go, elastic, same thing. All the quality that apply to cloud computing should be applied to the networking side of that. The other aspect that we look is also to distribute the cloud computing. Now we have those huge data center, a few places in the world. But then when you try to share content and move content around, you need huge bandwidth, huge chunk of networks just to transport that information from the server or the storage where you have in the data center to the end user. Well, if you try to get those servers closer to the end user or closer to the enterprise that's going to use that content or that service, then you save on the connectivity. Then that should be part of the equation. The connectivity between the different data center and the end user and the users of those services should be taken into account in the equation. So for that, we need to maybe distribute some of the computing resource and the storage resource in the network, closer to the enterprise and the users. Yeah. So the idea is to integrate computing, storage, and network. So this is cloud architecture, or the overall architecture that we came up in Sail. The idea that we have end users that can describe the infrastructure that they require. And the infrastructure means what type of servers they need, what type of service they need on that servers, what type of storage they need, how they want to connect them, what type of connectivity they're going to have, what type of constraints they have on the connectivity. I'm going to use very little bandwidth between those two servers, but they need to be very close to each other because the answers need to come quickly. While in some other case, between servers, you don't really care about the latency, you care more about the bandwidth. I need to be able to transfer a lot of information from that server to that server. So you need to describe your virtual infrastructure in a way that the cloud network provider will be able to deploy that application maybe not only in a single data center, but in a set of data center, and maybe even in the network. Yeah. So there's a few concepts I'm going to mention. I'm not sure that all of these are going to be covered later today, but at least you can get more information out of that on the same website in the deliverable. So what we have done is that we have improved a language which is called VXDL, Virtual Infrastructure Description Language, that allows you to describe all your infrastructure and how different pieces relate to each other. Out of that, we've been able to take the goal translation, do some goal translation that is based on those constraints. How do you deploy the application? And then decompose the virtual infrastructure maybe in some smaller pieces that are going to be deployed in data centers and in the network. Then, of course, we need to define a delegation mechanism. Not only delegate, you need to create that virtual infrastructure, create that that part into the data center, that part in this network. But we need somewhere, this delegation needs to be able to delegate the authority of connecting different pieces from different data centers together. So there's also really delegation, not only of creating the infrastructure, but also make sure that you delegate the authority to do that. If there was also already an API from Open Grid Forum, what was called OCCI, Open Cloud Computing Interface. But since it didn't include the network aspect, we added this OCNI, which is Open Cloud Networking Interface, that allows to create the network, connect things, put some constraint on the network, and how things are going to be connected. We provided some resource management, distributed resource management. If you have a large data center, or if you have multiple data centers, how do you make sure that you get a nice resource management? How do you manage all your resources in your network? And you need to do that in a way that it won't fail. So you can have that on a single machine somewhere in one corner of the data center. You need to be able to distribute that in multiple nodes and make sure that you're able to recover from failures. Since we need to connect the different pieces together, we need to have some communication between the different domains, between the data center and the network, to make sure that we connect the right pieces together. Since the user or the overall broker doesn't know about the details in each data center, you just can send, I'm going to create that virtual infrastructure here, you're going to create that part here, and you need to connect them together without knowing how they're going to be actually implemented in each of the domain, and without knowing what are the actual resources that are going to be used. So somewhere we need to create some abstraction level to do that, and we need to have some protocol to be able to communicate between the different domains, to be able to synchronize on which pieces you're going to connect. And of course, you need to do fault management. If you have a virtual infrastructure which is spread over multiple domains, you need to be able to monitor that, and you need to be able to make sure that if there's a fault, you're able to find where that fault is and recover from that. So there's going to be a bit more about network virtualization later today. And also, there's going to be some hands-on on cloud computing with OpenStack. So, hope you'll enjoy that. The third technical aspect, topic that we studied in SAIL is open connectivity services. In the past, connectivity was mainly related to telephone. I mean, there was only telephone. Where's the fixed line? Fixed line. Very few. The old people, I guess. Now, in the past, connectivity was about connecting places. Every home, or we could take for granted that almost every home has a phone or some way to connect. Now we're connecting people. Now everyone has a mobile device. So we're not connecting place anymore. We're connecting people. So that means we need to reach a huge, a greater number of devices and places. But that was, from the last 10, 15 years where now everybody has a mobile phone. But now what's going to come is that we need to connect things. Everything that will have to be connected, that could benefit from being connected, will be connected. So that may include maybe meters in the street for the parking. That may include your eating system or whatever you think that could be benefit from being connected will be connected. So that means that the number of places or devices that we need to connect goes from, instead of being a few billion, now it's going to be 50 or even 100 billion, depending on the scenarios that we look. So the connectivity service that we need to define needs to be able to scale and be able to adapt to that scale. For example, in 2002, the number of mobile devices exceeded the number of landline to access the internet. And also, last year the number of smartphones have exceeded the number of PCs, and this does not include tablets, which get a kind of huge demand from the network, from the customers, and also put some stringent requirements on the network. And a side effect of that is that now in some countries the access to internet is not done anymore from the PC, it's done from the tablet and the mobile devices. For example, in India last year, the amount of traffic coming from mobile devices has exceeded the traffic from PCs, from fixed nodes. And we're going to see that in more and more countries. So for that, we need to define the right services, and we need to make sure that all those devices can communicate all together. Since that puts a huge with pressure on the infrastructure, we need to find a way that those devices can communicate without the infrastructure, being able to connect directly to each other. So in OCONS, we have looked at kind of two sets of services. One to support network of information. How do we share content better using new connectivity services? And the other one is about cloud networking, about what are the services that we require from the network to be able to better support cloud networking. So in SAIL, I will just mention the key services that we have. One is about the disruption tolerant network and mesh support. That means devices that are not always connected to the internet, but that get partial connection or intermittent connection to the internet. How can we share content? How do we use the application in that context? The other one is about multi-interface and path selection. If you have a device that can do 3G, Wi-Fi, Bluetooth, or whatever new connectivity service technology that will emerge, how do we best use all those connectivity the best way? How can we use multipath? If you connect it to multiple network, can we use those multiple network to get access to the content? better we do? What are the best strategies? Do we do load balancing between them? Do you pick the best one, and so on? That's kind of the question that we have. Of course, it's about mobility. Currently, in the network, as soon as you connect to your device, there's a lot of resources in the network allocated for you in the network, so you can use mobile services. But in 80 or 90% of the case, whatever call that you're going to do, whatever service that you're going to do, you'll do it in the same cell, which means that we've allocated a lot of resources in the network to support your mobility, but you won't use them for efficiently. So, can we find better ways to maybe allocate those mobility resources in the network only when you're going to be on the move, not as soon as you connect? And also, can we, from a domain point of view, be able to better optimize the resources in the network when you're moving? Also, how do we optimize the data center connectivity? I'll talk about the elasticity of cloud computing. How does the network support the elasticity on the connectivity? If you use a lot of bandwidth, and more than you start to create congestion in some point, how can we allocate you more resources in the network? Maybe doing some type of load balancing, some type of multipath, or how can the application interact with the network to be aware of this congestion and excess of resources that are required? And same thing, if the application doesn't use those resources anymore, how can we make sure that they're going to be freed rapidly so that others can use it? And finally, there's one service that we created, which is one service to find them all, one service to rule them all. That's the orchestration service that should coordinate between those different services and make sure that we use them in the best way. Andreas and some others are gonna talk about that tomorrow. Most of the day is going to be focused on open connectivity services. But in life, there's not only technology. I know young students, they usually care mainly about technology, but there's also some side effects of that, business and social aspect of that we're also looking into in SAIL. We have a work package dedicated to that. How do we fit in those technology fit in the existing world? First is migration. How do we get from here that we are today to what we're proposing in SAIL? So we need to find the business incentive. Currently, for example, NetInf competes with Content Delivery Network. That's always things in place, and many of the Content Delivery Network don't really perceive well NetInf because they see that as a threat rather than an opportunity for them. And also, in cloud networking, is it better to increase the meshing in the network by putting more fibers, or is it better to distribute the computing part in the network by distribute them in the network? So there's a bunch of business issues that we need to look at. Also, we would like to be able to do an evolution of today's internet to what we're proposing in SAIL. We want an evolution instead of a revolution. If you look at IPv6, for example, which was more kind of revolution, even it's quite close to IPv4, that still require that every node in the network needs to be changed. And each application needs to be changed. How can we make sure that we can evolve from today to what we put in SAIL without having to replace all the nodes in the network? One step for that is standardization. Of course, SAIL is involved in some aspect of the standardization. For example, there's in ERTF, the research branch of IETF, there's a working group which has been created on ICN, Information Centric Networking, and it's 2 of the 3 chairs are from SAIL projects. So I guess we're going to have good grip on that. But there's also some other working group, like for Decade, that we're involved. Decade is about the distributing content. On the elastic networking part, MEF, the Metro Internet Forum, is looking at new services to be able to have, they call it dynamic responsive internet, which is mainly about carrier internet. What are the parameters that we need to put on the internet services that we have deployed today in the operator network to be able to scale up and down and add this elasticity. Maybe not directly standardization, but somewhere, people working together. OpenStack, for example, it might be an opportunity for SAIL to try to bring some of the results that we have in the community. Of course, there are a bunch of legal aspects also to information-centric networking. Copyright. What about copyright? If you're able to keep copies of the content everywhere, what happens to the copyright? If anybody can access to that content, how do we manage the access control? I mean, do we make sure that we can access to that? Do we need to change the regulation? And so on? The internet actors come from different countries, but each country has its own regulation. How can we harmonize that? Will that have an impact on how the technology will be deployed and how we're going to use them? Of course, lawful intercept. Every country wants to make sure that they can have an eye on the criminal use of internet. How can we allow that without breaking the privacy and all the other confidentiality aspect of internet? And also, if you able to retrieve the content from your neighbor's PC using NetInf, how do you make sure that how do you do lawful intercept on that? And anything related to identity theft, but that's not typical to what we have in SAIL, but typical to current internet. Privacy and trust. We leave all type of traces when we go on the web. We leave cookies, Twitters. So some of them we leave explicitly. We divulgate a lot of information on those social networks, and also when we some of them is explicit, some of them is more implicit. There are cookies, and now the ever cookies, which mean the cookies that can hardly be deleted. Search histories on different websites. GPS aware application that allows application from the web to track you, know where you are, and so on. How do we tackle that? And one more question is, now we can be influenced by the application. It's okay to have all this information, but sometimes, for example, if you go on Google or on Facebook, all the information that's going to be shown to you might be filtered by the application provider. So it might be the case that at some point that filter will get tighter and tighter, and you'll be able to only have one view of the internet or of the world that those large content or application provider will allow you to have. How do we handle that? And also, you put a lot of information on the cloud. Who has access to that? Do we really know? So one question that we could ask is, are we implementing Big Brother? And do we care? Okay. What else in the future? I'm coming to kind of conclusion in a few minutes. What else do we see in the future? What do you see? A few other topics that worth mentioning. Internet of Things, as I mentioned, any devices, any object that will benefit from being connected will be connected. So how do we make sure that we have machine-to-machine communication, efficient machine-to-machine communication? How do we manage all this huge data that we're going to collect from all those devices? And if we have a lot of those small devices that usually sometimes small devices out on the field, how do we make sure that we have power-efficient communication? How do we integrate that into the protocols and so on? And of course, all things related to privacy and security. The other topic worth mentioning is semantic web. can we make sense of all this information available? How do we make sure that we, instead of having just use keywords, how can you put more semantic in that? So there's work ongoing in WTC to try to define a semantic framework where you should be able to describe not only by keyword but a bit more refined than that. Then how we can make knowledge out of all the information that we have. And of course, if we have 50 billion of devices, you're going to need a large infrastructure to be able to support that. What are the tools, the new tools that we need to put in place to support that? Those networks don't manage by themselves. Somewhere we need to put all the tools to have this, what we call self-organized network. And how can we do that? Autonomic networking. You don't want to configure the IP address on each of the small devices that you have. You don't want to put a password on each of the small devices that you have. So somewhere you need to find new ways of managing all those devices. And software-defined networking, that's a good trend in the last few years. Whatever that means, I think we need to keep an eye on that. For some people, software-defined networking is about having, let's say, a higher abstraction of the network and be able to manage the network in a more abstracted way. For some people, it's more about be able to define new ways that the information would be forwarded in the network, or new ways to connect the devices by being able to do that. So we need to, I guess that's something that someone maybe will have to explain to me what exactly software defined should be about. So as just coming to the conclusion, the use of internet is evolving. Today it's mainly about content sharing. It's about elastic demand that should be applied both to computing, storage, and connectivity. There's an increased number of devices and applications and new ways to connect all of them. And of course it's all about mobility and wireless and so on that we need to take about. And the sales solution is about the key elements of sales solution is about information-centered networking, cloud networking, and open connectivity services. So my last question to you is, what will be your internet? What will your children take for granted?